This week, NASA says scientists have made the biggest step yet towards discovering whether there was ever life on Mars. A rock sample collected by the Mars rover Perseverance contains potential biosignatures which could suggest ancient signs of life. Professor of Earth and Environmental Sciences Douglas Jerolmack has been studying the dried surfaces of Mars and other icy moons to predict habitability and joins me now for tonight's interview. Professor, thanks for joining me. How exciting is this week's news? And help us understand it a little.
Sure. To talk about how exciting it is, I'll just provide a little bit of context. So, the name Perseverance for the rover is really apt because it's been a long, hard slog for scientists trying to understand if Mars was ever habitable and if there's life that was ever on it or is there now. And so what I mean by that is that for decades now, we've had observations from space and even from telescopes of Earth of river channels. Those river channels were active around 4 billion years ago. And in the last couple decades, we've had ever increasing resolution of satellites and then rovers on the ground that have been observing river channels. And then we get on the ground and those river channels have mud and pebbles and things like that we see on Earth. And then we start to examine those pebbles and we see that there's interesting chemicals and minerals. And where this latest study comes in is that there are some minerals that are minerals that when we find them on Earth, we find them in places where there's been water at comfortable temperatures, and that may have had microbes that helped produce them. And so we've never found minerals like this on Mars before. They're pretty exotic, and there's a possibility that life may have been involved in forming them. So that's new.
Oh, that's great. I mean, because it's a clear explanation, which was sometimes missing in some of what I read about it. Tell me about your work with surface fractures and what that tells us about possible life on other planets.
Right. And so the idea is that, when we're searching for life on other planets, we're always after water. We're following water because on Earth, we've never found any kind of life that can exist without the presence of water. And so there are two kind of signatures that we can see from water that's related to crack patterns. One of them is that when we see ice cracks in a very special way because of the fact that it cracks and heals and cracks again. And so it makes this overprinting pattern like you see in these pictures. And the other kind of special crack pattern that is associated with water is mud cracks, like you see now. Of course, we see mud cracks on Earth on dried up lake beds and next to a river, but there's special signatures in the geometry of these mud cracks that can tell us whether it was just a one and done event, that the mud dried and cracked, or whether it got wet and dry and wet and dry. And that wetting and drying actually causes the geometry to change. And when we see hexagonal-like mud crack patterns, it actually tells us that we had persistent wetting and drying of water. And we've actually seen hexagonal mud cracks on Mars in ancient lake beds, and that's something that my group and others have worked on. So there's multiple signs coming together that there were environments that had liquid water present for a long period of time, which are just additional constraints on life on Mars.
We have 15 seconds left, Professor. Anywhere else other than Mars you've seen those patterns?
Not the mud cracks, but the crack patterns that we see in ice, we also see on Europa and Enceladus, which are icy moons that are interesting targets for looking for life in the future.
Professor Douglas Jerolmack, thank you so much for being with us.
Sure, thank you.